Hi people, this video is on radian measure and angles on the Cartesian plane. I just want to do a quick refresher on the unit circle with radians. So this unit circle is filled in with all the degree measurements, all the coordinates. I just want to talk about radians. So if you look at this box right here, it should make sense that this should be 0 radians because 0 degrees would have to be 0 radians. And don't forget that pi radians is equal to 180 degrees. So at 180 degrees here, we can say that this is pi radians. Well, if I take a look at this right here, 90 degrees is half of 180. So this would have to be half of pi, or pi over 2 up here. Okay, and then if this is pi right here, then if I go around another extra pi right here, this will bring us to 2 pi. So don't forget that 360 degrees right here means 2 pi. So we also know that 2 pi radians is equal to 360 degrees. Okay, all right, cool. So now if this right here is pi over 2, we have another pi over 2. So this is technically 2 pi over 2, right? Then if we go another half of a pi right here, so this is another extra half of a pi, this will tell us that down here, this would be 3 pi over 2. Again, half of pi, 1 pi over 2, 2 pi over 2, 3 pi over 2. And then if I were to extend this, then I would come back to 4 pi over 2, but 4 pi over 2 is 2 pi, which is what we have right here. Okay, so now let's look at the 30-degree angles. So if you look right here, this is 30 degrees right here. Another 30 degrees is at 60 degrees. So here's one 30-degree angle, two 30-degree angles together, three 30-degree angles, 4, 5, and 6. So if you notice, in order to make a full pi, this would be 1/6 of pi. So this would be pi over 6. But remember, if we know that pi is 180 degrees, in order to get to 30 degrees, we would have to divide this by 6. So then we can divide this side by 6 as well. So that's why this right here would end up being pi over 6. Well, if this is 1 pi over 6, then this right here is also 1 pi over 6 away from pi. Our reference angle here is pi. So here I can say that this angle measurement right here would have to be pi minus pi over 6. Well, if I get a common denominator, I could say 6 pi over 6 minus pi over 6. So this would have to be 5 pi over 6. And it's really important that you know your fraction facts when we're dealing with radians. Okay, so now for this other pink angle right here, again, our reference angle is pi over 6. It's 30 degrees. So I'm going to go through and I can say that this is pi over 6 more than pi. Well, pi over 6 more than pi means it's 1 and 1/6, or 6 pi over 6 plus another pi over 6. So this would have to be 7 pi over 6. And then our last pink angle that we have here is going to be pi over 6 away from 2 pi. So to figure this out, I would have to do 2 pi minus pi over 6. Well, to get a common denominator, this would be 12 pi over 6 minus pi over 6, which would mean that this would be 11 pi over 6. All right, so now I'm actually going to take a look at the 60-degree angle right here. So for the 60-degree angle, here's one section. So I'm going to see how many 60-degree angles I'm going to need to make 180 degrees. So here's one 60-degree angle, here's 2, and then here's 3. So this is broken up into 1, 2, 3 equal parts, which means that 60 degrees has to be pi over 3. But again, if pi is equal to 180 degrees, in order to get to 60 degrees, I would have to divide this by 3, which means that I divide this by 3, so 60 degrees is pi over 3. Another reason why this would end up being pi over 3 is because, let's look back at our pink angles that we have right here. If this is 30 degrees and it's pi over 6, this is 1 pi over 6. Another 30 degrees would be 2 pi over 6, but 2 pi over 6 reduces to pi over 3, so it should all connect together. Okay, so now this angle right here, this 120 degree angle right here, this is pi over 6 away from, like our reference angle here is pi over 6. It's pi over 6 away from pi. So to figure out this angle here, I would have to do pi minus pi over 3. But pi is 3 pi over 3. Subtract a pi over 3, and you would get 2 pi over 3. So this is 2 pi over 3. That should also make sense because if this is 1 pi over 3, this would be 2 pi over 3. To determine what this is in terms of pi, I would need to see that this is pi over 3 more than pi. So I'm going to say that this right here is pi plus pi over 3, which would end up being 3 pi over 3 plus pi over 3, which is 4 pi over 3. Again, that should make sense because here's 1 pi over 3, 2 pi over 3. Don't forget this is 3 pi over 3, and here we are now at 4 pi over 3. Which brings us to this one right here, which would have to be 5 pi over 3, but we can also look at it as being pi over 3 away from 2 pi. So if I do 2 pi minus pi over 3, this would be 6 pi over 3 minus pi over 3, which is 5 pi over 3. Okay? All right, so those are all our 30 and 60 degree angles. Now let's talk about the 45 degree angle. So this 45 degree angle right here, we have 1 45, 2 45s, 3 45s, 4 45s to make 180. So this would have to be pi over 4. But again, if pi is 180 degrees, to get 45 degrees, I would have to divide this by 4. So I divide this by 4, so that's why pi over 4 is 45 degrees. Well, if this is 1 pi over 4, and this is 2 pi over 4, then it should make sense to you that this should be 3 pi over 4. But another way to think about this right here is we can say that this is pi over 4 away from pi. So we can say this is pi minus pi over 4. So I get 4 pi over 4. That's my common denominator is 4. Minus pi over 4, which would give me this 3 pi over 4 that we have here. Again, fractional understanding is crucial. Okay, so now for this one right here, this should be 5 pi over 4. How do we get it? It's pi plus an extra pi over 4. So this is pi plus pi over 4. Getting your common denominator, it's 4 pi over 4 plus pi over 4, which would give us 5 pi over 4. Okay, and then lastly, this one right here is pi over 4 away from 2 pi. So to figure this out, I'd have to do 2 pi minus pi over 4. So our common denominator is 4. This would have to be 8 pi minus pi over 4. So this would give us 7 pi over 4. Okay, so it says find the 6 trig ratios for each of the angles in quadrant 1. So if this right here is pi over 4, because that's what the first section of questions is saying to us, we know that the coordinate is going to be root 2 over 2, root 2 over 2. Okay, so what I like to do is I just like to draw in like a rough sketch of my unit circle. We know this is pi over 4, and then I like to write the coordinate down right here. And I also like to just remind myself that in the unit circle and only in the unit circle, sine is y, cosine is x, tangent is y over x, cosecant is 1 over y, secant is 1 over x, and cotangent is x over y. So if I want to find the sine of pi over 4, remember the sine is always going to be the y value, and here the y value is root 2 over 2. So here we can say that sine is going to be root 2 over 2. Okay? Cosine is always going to be the x value, and the x value here is also root 2 over 2. Tangent is going to be y over x, and we know that the y is going to be root 2 over 2, and we know that the x is going to be root 2 over 2, and anything divided by itself is always going to be 1. So here we know that the tangent is going to be 1. Now, for the cosecant, remember cosecant is 1 over y. So remember, this here means that I need to do the reciprocal of y. And if y is root 2 over 2, then I'm going to do the reciprocal of that, which is 2 over root 2. But then I need to rationalize that denominator. So I'm going to multiply numerator and denominator by root 2 over root 2. So I end up getting 2 root 2 over 2. The 2's cancel, so this would just be root 2. And then secant is going to be 1 over the x, and so it would be the reciprocal of the x. And we just simplified that radical and rationalized the denominator to root 2. And then cotangent is always going to be x over y. And because the x is root 2 over 2, and the y is also root 2 over 2, our final answer here is also going to be 1. Also, I could just take the reciprocal of 1. All right, now for sine of pi over 6, I'm going to do the same thing. I'm going to draw out my unit circle right here. Pi over 6 is 30 degrees, so I know it's going to be like somewhere right here. And I know that my coordinate's going to be root 3 over 2, 1/2. So we know that our x value is going to be root 3 over 2. We know that our y value is going to be 1/2. So if I want to find the sine, I just have to use my y value, and I know that my y value is going to be 1/2. So the sine of pi over 6 is 1/2. The cosine of pi over 6 is the x value, which we know is going to be root 3 over 2. And then we know that the tangent is going to be y over x. And we know that the y is going to be 1/2. We know that the x is going to be root 3 over 2. Now listen very carefully to this next piece right here. I'm going to simplify this complex fraction by multiplying by the common denominator, which is 2. And when I multiply 1/2 by 2, the 2's cancel. When I multiply root 3 over 2 by 2, those 2's can also cancel. So I end up with 1 over root 3. But I need to rationalize that denominator. So I end up getting root 3 over 3. This is tangent of pi over 6. Okay, so now cosecant is going to be the reciprocal of the y value. So the reciprocal of 1/2 is going to be 2. Secant of pi over 6 is going to be the reciprocal of the x value. So this would be 2 over root 3. But again, I need to rationalize this denominator here. So I need to multiply numerator and denominator by root 3 over root 3. So I get 2 root 3 over 3, and that's completely simplified. I guess I should put boxes around all of these. Okay, and then lastly, cotangent is going to be x over y. And we know that the x is going to be, I'm going to just zoom in on this so you can see what's going on here. We know that the x is going to be root 3 over 2. And we know that the y is going to be 1 over 2. And I can simplify this by multiplying by my common denominator of 2. Those 2's cancel, those 2's cancel. So I end up getting root 3 over 1, which is just simply root 3. Okay, so now our last example that we have here is sine of pi over 3. So here's pi over 3, and we know right here that the coordinate would be 1/2 comma root 3 over 2. Same thing, we know that the y is root 3 over 2. We know that the x is 1/2. We know that sine is the y, so this is going to be root 3 over 2. We know that cosine is the x, so this is going to be 1/2. We know that tangent is the y over the x, so I'm going to say it's root 3 over 2. all over 1/2, multiply numerator, denominator by that common denominator of 2, gone, gone. So I end up getting root 3 over 1, which is just simply root 3. So now cosecant is the reciprocal of y. So I'm going to do the reciprocal of these values right here. I would end up getting 2 over root 3. On the previous page, in the previous question, we already rationalized that denominator here, and we showed that we should end up getting 2 root 3 over 3. Secant of pi over 3 is the reciprocal of cosine, so I can just say it's 2 over 1 or just 2. Cotangent, I can either do x over y, use the x here and the y here, or I could just do the reciprocal of this value right here, which might be easier. I want to show you both ways to do this. So it'd be 1 over root 3 multiplied by root 3 over root 3. You get root 3 over 3, and so cotangent of pi over 3 is root 3 over 3. So you can do it this way, or you could do it this way. It doesn't matter. Either way, you'll get the same answer. Okay? All right, so now the next questions ask us to determine the exact value of each trig ratio. So the first one that we have here is sine of pi over 2. So if I have my unit circle right here, and I take a look at pi over 2, this right here is pi over 2. The sine is always going to be the y value, and the y value here is 1. So sine of pi over 2 is just simply 1. In the next example, it's asking you to find the cotangent of 3 pi over 2. So remember, this right here is 3 pi over 2, and as a coordinate, this is 0, negative 1. And cotangent is always going to be x over y, and the x here is 0 over negative 1, so the answer for cotangent of 3 pi over 2 is 0. Okay, cosine of 5 pi over 4. So for starters, we know that our related acute angle here is going to be pi over 4, because this is 1 pi over 4 more than pi, right? If I take pi and add an extra pi to it, I should get 5 pi over 4. So if we know that, let me make this look more like pi over 4. So if we know right here that pi over 4, that 5 pi over 4 is related to pi over 4, and if we know pi over 4 is root 2 over 2, root 2 over 2 as the coordinate, then we know this would be negative root 2 over 2, negative root 2 over 2, and cosine is the x value, so the answer to this is going to be negative root 2 over 2. Okay, and then cosecant of 11 pi over 6 is going to be, so here's 2 pi, which out of 6 is going to be 12 pi over 6. So 11 pi over 6 is only 1 pi over 6 away from 12 pi over 6. So here our reference angle is pi over 6. Well, if we know that pi over 6 has a coordinate of root 3 over 2, 1/2, then we know that 11 pi over 6 has a coordinate of root 3 over 2, negative 1/2, because the x value is still positive, the y value is negative. And then remember, cosecant is 1 over y, or the reciprocal of y. So I'm going to take my y value, do the reciprocal of it, and I end up getting negative 2. Okay, in this next question, we know that tangent of theta is negative 7 over 24, so it's a negative. And we know tangent is negative in quadrants 2 and 4. So I'm going to draw a diagram of both of my triangles that I could possibly get. This says that theta is between 0 and 2 pi. So right here, we know it's going to be in quadrant 2. That's one possibility. I'm going to label beta here as my related acute angle. So it's not theta, it's beta here. And we know that right here, this is going to be 7 over negative 24 over here. And then we also know that this is going to be in quadrant 4 as well. And it's the same thing, but this time this is going to be negative 7 over a positive 24. But don't forget right here that we know that this is pi, and we know that this is 2 pi. And then here, this is also beta. So the first thing I'm going to do is find my related acute angle by using tangent of beta. Now the related acute angle would be in quadrant 1, and we know tangent is positive in quadrant 1. So we would say that this is 7/24. It would be the positive version of our angle here. So beta would have to be the inverse tangent of 7/24. Okay, so here we're going to say beta is approximately, make sure you are now in radian mode. I'm going to do the inverse tangent of 7/24. And I end up getting 0.2837, so on and so forth. I'm gonna actually store this in as B into my calculator here, because this is not my final answer and I want to have like an accurate answer right here. So we're going to say here this is approximately 0.2838. I'm going past the hundredths place because this is not my final answer, but either way, I'm going to use B in my calculator instead of typing in 0.2838. Okay, so our first angle, our first possibility for theta right here, so I'm going to call this theta 1, is beta away from pi. So to figure out my first theta, I would have to do pi minus beta, which is approximately, here I'm going to type in pi minus, and then I'm going to type in B right here. So this is approximately 2.86, rounded to the nearest hundredth. This is 2.86. So here's one answer. But then there's also another theta that is in quadrant 4, and that's all the way around here. So I'm going to call this theta 2. And to find theta 2, that is beta shy or beta away from 2 pi. So to find theta 2, I would do 2 pi minus beta, which is approximately 5.939, rounded to the nearest hundredth. This would be 6.00. And these are my two answers. And that's it for this video. Let me know if you have any questions.